Go.
You guys already know what time it is. Pre-calc semester 2 video project. It's your boy Elijah. Welcome back. Today we are doing, you guessed it, trigonometric equations and identities. To start off, I want you guys to take your calculators, put them in radian mode. We're going to be dealing with a lot of radians. Secondly, I want to talk about a little problem I had with this unit, and that was solving for x with trig identities. Now, with any other equation, there's usually one answer for x, or maybe two, depending on the equation, but for trig identities, we have to realize that there are an infinite amount of solutions. If we look at the unit circle, x could be here, and here again, and here again, and here again, and it's because there's a constant rotation around the unit circle. Now, unless we have a domain, our solutions for x are infinite. And that's what I want to focus on primarily today, is that idea of domain restricting our x values in the solutions. Example number 1. Solve for x. 2 sine x minus 1 equals 0. Now, our domain in this problem is going to be 0 to pi. Step number 1. As we see here, maybe we can do something. Let's isolate our sine x. First we add both sides, plus 1, divide by 2 for the inverse. So now what we have is sine of x equals 1 over 2. Isn't that right? Now, if we draw a unit circle, and sine of x is 1 over 2, we know that sine is the y. So, it has to be here and up. But we also know that our domain goes to pi. So it has to be in either the first or the second quadrant, or maybe both. Now, with that said, we know that based off of calculations, sine of 1/2 is sine of x equals 1/2 is going to equal 5 pi over 6 on this side, and pi over 6 right here. Pardon my penmanship and my board. But essentially, we know this because it goes up 1/2, and as we know, this is 1 as far as y is concerned. Same for here as well. Now, if we want to check if those are right, if 5 pi over 6 and pi over 6 are our answers, we then can use algebra and our calculator. As I said, sine of x equals 1/2, and this is how we check. We take the inverse sine and we see in second inverse sine 0.5, mode is in radians. We get 0.523. Now, if we take pi minus 0.523, we get 2.617, give or take, and this should equal pi over 6. and this should equal 5 pi over 6. If we plug this into our calculator, 5 second pi over 6, we'll see that we do in fact get this answer, and the same thing for here. And this is just a good way to check our answers. Using our calculator. Moving on to problem 2. Find the exact solution of square root of 3 sine x equals cosine x with the domain of 0 degrees to 360 degrees. Now, as I said earlier, we are in radians, but because they give our domain in degrees, I highly suggest turning your calculator into degree mode. Mode, degree. From here, we know this. Now, when we're faced with these problems, we get caught up, and it takes a lot of abstract thinking. For this one, think about this. If we divide both sides by square root of 3 cosine x, what will happen? This is what will happen. Over square root of 3 cosine x over square root of 3 cosine x. Now what do we see here? We see square root of 3 sine x over square root of 3 cosine x. We have square root of 3's that we can cancel out. Over here on this side we have cosine of x's that we can cancel out. This then leaves us with sine of x over cosine of x equals 1 over square root of 3. Now, if we go into our formula booklet, or based off of previous knowledge, we know sine of x over cosine of x is tangent. So if we rewrite this, tangent of x equals 1 over square root of 3. Then from there, we can take, again, our calculators and do inverse tangent on both sides. And what we find is second inverse tangent, 1 over second square root of 3. We get 30, as in 30 degrees, because we are in degree mode. Now we know that there's another solution because tangent, as we look at the unit circle, is going this way. And if it's 30 here, there has to be a value here as well. So what we do is we take 180 plus the 30 to get 210. And those are our two answers for x in terms of degree for that problem. 30 degrees and 210 degrees. Perfect, perfect, perfect. Moving on to the third example. We are solving sine x equals negative 1/2 with the domain of 0 to 3 pi. Now, if we draw our unit circle and we see our domain, 3 pi, 1, 2, 3. So it's one full rotation and a half. But if we look at sine of x equals negative 1/2, we know that it has to be down here, right? So we don't even need that half a rotation up here. And we know that sine of x equals negative 1/2. Those values in radians are going to be 7 pi over 6 and 11 pi over 6 here and here. Now with our domain, these are the only answers. And the reason why I chose this problem, it's very easy, but it shows us that our domain might give us more than we actually need. And in this case, our answers fit in the domain 0 degrees to 2 pi, or 360. And that's pretty much all I have for you guys. I just wanted to show you the value of using your unit circle, drawing it out, using your calculator, inverse functions. And now here are your homework problems. Solve for x with the domain of 0 to 4 pi. There's 4 pi. A is 2 cosine x minus 1 equals 0. B is square root of 2 sine x equals 1. And C is going to be tangent of x equals 1. So what I want you to do is find all the possible solutions for x given the domain 0 to 4 pi. Pause the video if you need to. Do those. And your answers will be, for A, x equals pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. For B, your answer should be x equals pi over 4, 3 pi over 4, 9 pi over 4, and 11 pi over 4. And for C, your